Is Leetcode 700, you can say, questions that search in a binary tree. So how we are going to search search anything, any nodes, any value in the binary search tree. So data is different things, but what we have given here, we will look into that first. Okay, so we have given the root of a binary search tree, BST, and an integer value val. Okay, now we have to find the node in the binary search tree that the node's value equals to the val, and it will return the subtree rooted with the node, you can say. Okay, so I was saying, so we have given what? We had given 4 as a root value. All the left childrens are smaller than the root, right? Like this we have given actually. Okay, and this is nothing but our 7. Okay, so in this case what we have to do, we have to check, because root is not matching. When we are doing search, we are passing the root value and then x, right? X. So the x is not matching with the root value, right? In that case, it means what? So first condition we have already checked. If the root dot val is equal to x, then we will return what? Root. Then we will return root, right? That is already done. Means we are comparing with this one. Now what we have to check, we will make a condition. Means if it is equal to x, then we will return the root. Otherwise we will check if root dot val is what? Greater than or less than, right? So if root dot val is greater than what? The x, the search value, means 4 is greater than x, that we are, x is nothing but what? 2. Right now we have x is 2, so it is true, right? Means we have to return what? This whole subtree we have to search, right? In that case what we will do, we'll do recursive call, right? Recursive call, how we are going to do, we'll do return same function that we have, we will call, that is what? Search. What we are going to pass? In that case, if this is root, so this is become what? Root dot left node, right? And this is our root dot right node, correct? So we will pass root dot left. What we will pass? Root dot left we will do, right? And what is the search value? X, correct? So that we will pass. Okay, now think, if this value is going to match again, right? Because this recursive call, so we got here, because it will call the same function again here, right? So now the control will, when the control will reach here, you will get the root, means what? You will get the 2. So you will return the whole root dot left value as a root, because it is returning root, right? And you will get the data, right? Similarly, you will do if root dot val is less than x, right? If root dot left root dot val is less than x, then in that case what we will do, we will call the recursive call search root dot right and then x. Similarly, if these 3 cases are not matching, means we don't have the data in the our data is not matching, we will return null, right? And that is done. So in this way, like, we have to work on the binary search. Okay, we have given root, and this is nothing but our value x that we are talking about search, right? This is your search BST and this is tree node, right? The first condition I told you, we have to check a condition, right? What condition is there? If the root value itself is nothing but null, means we don't have tree node to search, right? Because it is already null. So we will say we don't have the data because our tree itself is null. So we will return null data, right? Tree node will return null object. Okay, means this is nothing your base case, corner cases, right? Let's suppose this is called base case, because if we are thinking all the corner cases, right, so where our recursive call will stop. If you have understood the recursive functions, right, so recursive function will call itself, so where it should reach, because we are starting from the top, when it will reach to the bottom, right, there should be a terminate condition, and this is our terminate condition, right? We'll talk about again. Wait, again another case I was talking about, if this is the root is not null, means there is some data in the tree, right? Tree is not null, means we'll check first what root itself, right? So root value, if it is matching with the search value x, if this two value is matching, in this case what we will do, will return what, will return root, means we have got the search, right? If it is not matching with that, means we have to check the root value is less than x or greater than x, that we have talked, right? So we'll check root dot val is less than x or greater than x. If it is less than x, then we'll go to the right. If it is greater than, we will go to what, left, right? So let's suppose we have greater than this. In this condition, we have root dot value is 4, right, and search value x is 2, remember? So what we will do, we'll return, we'll call the return, but we'll call the same function we'll call here, like this, okay? But in this case we don't need to do implementation thing, we are already passing root, so we'll call because see, parent root is greater than x, means 4 is greater than 2, means we have to go with the left subtree, then do left, and the x is the search value, it will be same, right? Similarly, we'll check for what, if the root dot val is less than x, means 4 is less than 7 in this case, right? So we'll return, let me copy this one, search, and then we'll pass what, root dot right, and we'll pass x search value. So now we got why we have written, because binary search is saying the root value is always greater than the subtree values, right? And the root value is always less than the left subtree, right? Right subtree, right? Like this. If it is not matching these three condition, means we have not found the what, the search value, means search value is not available in the tree. So let me run, and then we'll come again to check. Yeah, it's working. So let's discuss. Yeah, it's working. Okay, now what I was talking about, so I was talking about we have root value 4, then we have subtree, that is 2, its children subtree is 1, then its right children is 3, and its value is nothing but 7, right? Right subtree. Give me 1 second. Okay, so the first condition that we have made is base condition. Why we are making the base condition? Because see, base condition we are making because we are calling the in recursive calls, right? Here, right, we are checking recursive call. So this function will go again where, on the top level, and it will check again. So it will go to the infinite loop, right? So when it is calling from 4, it will come to 2, when it will come to 1, but there should be another children to run this program, otherwise it will go to infinite and it may break, right? So what is happening here, it will not stop actually, right? So in that case there is null data. After this we have null node, right? Here is null node in everywhere, right? We have null node, right? So when we reach to here, right, it should stop, right? First we have call control come to here, right? From here, right? From here we call here, then control came here, then control came here. When the control will come here, it should stop, right? That is why we have made the base condition. If the root is null, so root will come someday, right? If right now it is not coming because we have given the root value, we have given search, we have given, right? But there is a case that it will come null. When will it will come? When the recursive call itself again and again. First we'll get the root value 4 root.val, then we'll get the root.val is 2, root.val is come 1. So when will come after the 1, root.val is nothing but what? Null. So when we'll call root.null, root.val, it will go null pointer exception. So to escape from the null pointer exception, to handle the exception class, right? Exception handling, right? We have to make the base case, sorry, right? And it will terminate from there. Now let's talk about this first value right here. So when we are writing root.val is going to search the x value, means if we are talking about the search, right, if we are passing root and then the search value is 4, right? If the 4 itself is at here, we don't need to search go again down, right? All the recursive calls we don't require, we will get directly at this position. So that is why we have written here. If you are searching 2 here, then it should go control next to 2 here, right? And for that we are checking if the root value is greater than x, means the 4 is greater than 2, means we have to go to the root dot left, right? And that is why we have given here. Otherwise if it is less than, we'll check in the right side. Okay, means now you should understand what is BST. So BST, the root value is always greater than the left and always smaller than the right, right? With this condition, you have to perform an action, you have to write the code, you have to think about the program like this, right? And if anything not found out till now, you have to return the null here to handle the cases, right? Thank you guys, thank you for watching this video. If you really like this video, please hit subscribe and write some comments, write about some thoughts about you. I'll continue with some important questions that has been asked in the FANG interview, and even when I was giving interviews in the top companies. I have some notes. I'll go through that and I'll collect all the questions. Thank you for watching this video. If you have any questions, if you have any doubts, please ping me in the comment box. Thank you guys, thank you for watching this video.